Welcome to my channel FET Concepts CHM. This video is the first part of Junction Field Effect Transistor. Here we will see the operation and working of JFET. The full form of JFET is Junction Field Effect Transistor. Also, we will see the similarities and dissimilarities between bipolar junction transistor, that is a BJT, and the FET. This is the construction of FET, and these are the symbols of an N channel JFET, and this is the symbol of P channel JFET. So JFET is a unipolar device, that is, it depends on only one type of charge carrier, either electrons or holes. That is, since they involve single carrier type operation, that's why we call them as unipolar. That is, they do not, the operation do not rely on minority carriers. So there is a piece of N-type semiconductor. You can see here an N-type semiconductor, and the LEDs or the terminals are brought out from the lower end, which we call as a source, and the upper end here it is called as a drain. Two regions of P-type are diffused into the N-type of the semiconductor from the two sides. So these are the two P-type regions, and this forms the gate. The two gates are connected together in a normal JFET. Hence, we can say that there are two diodes, the gate to source diode, okay, the gate to source diode and the gate to drain diode. So this gate and the drain diodes. Operation of JFET. This is the circuit diagram for JFET. Supply voltage VDD is applied between the drain and the source. So this is the VDD supply, such that when the gate is open, that is, we are not applying any supply voltage to the gate, the electrons can freely flow towards the drain from the source. So the electrons will flow through this area. The gate source diode is reverse biased. That you can see that the gate, which is the P-type region, is connected to the negative terminal of the battery, and the source is N-type, it is connected to the positive terminal of the battery. So the gate source diode is reverse biased, making the gate current Ig is equal to 0. Hence the input resistance, which we denote as Rin, will be infinite. That is, the FET has a very high impedance, typically of 100 mega ohms. Also, we can see that the gate drain diode is reverse biased. Gate is connected to the P-type region is connected to the negative terminal, and the drain, which is the N-type, it is connected to the positive terminal. So the gate drain diode is also reverse biased. Hence both the diodes in the FET are reverse biased. Now, in the name of JFET, there is the field effect term. So the so-called field effect is related to the depletion layer around each P region. So the P regions or the depletion layer around the P regions are indicated by this black part. As the lower PN junction is reverse biased, there are depletion layer between both PN junction. When the electrons flow from source to drain, they must pass through the narrow channel between these two depletion layers. The more negative the gate voltage is, narrower is the channel. So in other words, we can say that the gate voltage can control the current. So we'll see the working. When VDD is applied, the free electrons start to flow from the source to the drain. And these free electrons have to pass through the narrow channel between the depletion layers. So they have to pass through this channel which is formed between the two depletion layers. The gate voltage controls the width of the channel. More negative the gate voltage, narrower will be the channel, because the width of the depletion layers or the area covered by the depletion layers will be more, and hence the channel will become more narrower and smaller will be the drain current. Almost all free electrons passing through the channel will flow towards the drain. So we can say that the drain current is equal to the source current. ID is equal to IS. Now we will distinguish between BJT and FET. BJT is a bipolar device, that is the charge carriers are of two types, the electrons and the holes, and as said FET is a unipolar device. Okay, there is only the charge carriers are of single type. BJT has three terminals called as emitter, base, collector. FET also has three terminals, but they are named as source, gate and drain. Input impedance of BJT is high, and in case of FET is infinite. It's very high. BJT amplifier has more voltage gain compared to the JFET amplifier. As the input impedance is very high, the voltage gain of FET is very less. BJT is a current controlled device. FET is a voltage controlled device. BJT is of two types, NPN transistor and PNP transistor. FET is also two types, but they are named as N-channel FET and P-channel FET. Thank you for watching this video.